Hi guys, and welcome to an AP practice problem video. As you're preparing for your AP exams this coming May, definitely try and watch a lot of these videos. They're very helpful. They helped me when I was taking the test, and just try and prepare yourselves as best as you can. And there's no reason you shouldn't get a 4 or a 5. So starting off, the question is, a particle moves on the x-axis so that its position at any time t is greater than or equal to 0 is given by x of t is equal to 2te to the negative t. So basically what this is saying is it's moving horizontally, it's only on the x-axis, so think of it like a number line, and at any point, at any time, you can figure out where the particle is by plugging t into the equation. So part A is find the acceleration of the particle at t equals 0. So I'm assuming you all know how to do derivatives. This is a AP class. We learned derivatives earlier in the year. So basically, for thinking of rates, we know that x of t is going to be position. And when you take the derivative of that, we know that that's the rate that it's going at. And the rate of change is going to be velocity. And if you take the rate of velocity, that is how much the velocity is changing. And we know that that's called acceleration. So that would be the second derivative of position is going to be acceleration. So to do this, the first step is to take the first derivative, and that would be 2e to the negative t minus 2te to the negative t. And that's just, we know the derivative rules. We get there by using our natural log rules. And so then you would take the derivative of that to get the second derivative, and you would end up with negative 2e to the negative t minus 2e to the negative t plus 2te to the negative t. Once again, using our natural log derivative rules and our exponent rules. So now we plug in 0 because we were looking for, because acceleration is going to be the second derivative. So we have the second derivative, and we need to plug in 0 because it's at t equals 0. And we're going to get, let me hide this, we're getting negative 4, because you plug in 0 to each of these, you get negative 2 minus 2 plus 0. Put them together, you get 4. So part A, the answer is 4. Basically just taking derivatives, plugging in numbers, simple, easy. You should be able to get that no problem. Part B now is find the velocity of the particle when its acceleration is 0. So when its acceleration is 0, we know, if we go back, we know that the acceleration is 4 at this second derivative. So when the acceleration is 0, what you do is we have the second derivative from before, which I think this is just factored out. Yeah, they factored out a 2e to the negative t. And we set it equal to 0 so that we can find out when t is 0. And we get that, or when the equation is 0, what t is going to equal to. So we find that t is equal to 2. So when the acceleration is 0, the time is 2. So then we would go back to the acceleration, or to the velocity, which is going to be the first derivative, and plug in 2. So the first derivative, we plug in 2, and we get negative 2 over e squared, and which is approximately, since this is a calculator problem, we can make approximations, which is approximately negative 0.271. And that is the answer to part B. Another simple one, you use the second derivative, set it equal to 0, find the time, and then go back and plug it into the first derivative. Part C, find the total distance traveled by the particle from t equals 0 to t equals 5. This is the part that's going to trip you up the most. It's a bit of an abstract concept, a little bit hard to picture. So basically, I'll just go through it with you. We have the first derivative again, which is going to be velocity. And we need to know when velocity is 0 because we need to know when it changes direction. So if you think about it like it's starting off going negative and then it comes back, at some point it's going to be completely stopped. It's going to be 0. So by total distance, that's including backwards and forwards. So at 1, whatever the unit of time is, at 1, we know that the velocity is 0. So from 0 to 1 and from 1 onwards, they're going in different directions. So now we have our critical points, which are x equals 0, x equals 1, x equals 5. Think about it like 1 is your local maximum. That is when the slope changes from increasing to decreasing. If you look at this graph, 1 is going to be your local maximum. So the velocity starts off going increasing, because since velocity is going to be the rate, the slope of this line. So it's always increasing until it gets to 1, and then it starts to decrease. And all the way down to 5, which is because it's 2t equals 5. And we're going to, so moving on. I don't know where the x equals 5 point, whatever. But moving on, so we need to do x of 1 plus x of 1 minus x of 5, because if you think about it like this, it's moving x of 1 is going to be from here to here. So from here to here, it's moving 0.736 up. And then it has to go back down that much over here. So think of it like it's going across and it's coming back, and then it's going a little bit further back, and that little bit further back is going to be 0.67. Actually, that's wrong. You go forward. No, it's going forward 0.736 and then going back 0.067, which is why it's x of 1 plus x of 1 minus x of 5. So you get 2 over e plus 2 over e minus 10 over e to the 5th. And since it's a calculated problem, you can approximate it into 1.404. And there you have it. That's your AP problem. Thank you for watching. I hope I explained it well. And good luck on your exam in May.